let us work on this ionic bonding worksheet. The way it works is, you look at this equation and then list down the atoms that you see in the equation. The first element I see is lithium and the second is chlorine. You look up valence electrons with the help of the periodic table. Lithium is group 1, so it has 1 valence electron. Chlorine is group 7, so it has 7 valence electrons. Electron transfer from metal, lithium being a metal will transfer electron. So lithium transfers 1 electron. Chlorine is a non-metal. It has 7 electrons. This electron that was transferred from lithium is accepted into chlorine. So now chlorine has 1, 2, 3, 4, 5, 6, 7, 8 electrons. 7 of its own and 1 transferred by lithium. And lithium has lost its electron, 1 electron, so it used to have 3, now it has 2. So the ions formed would be lithium becomes +1 because it lost 1 negative charge with its electron. Chlorine becomes -1 because it received that negative charge. So let's go and work on another problem. Let's work on MgS. So magnesium and sulfur. Magnesium has 2 valence electrons. Sulfur has 6. Magnesium will transfer 2 electrons to sulfur. Sulfur has 6 of its own and it gets 2 extra from magnesium. So magnesium becomes +2 ion by losing 2 electrons, and sulfur becomes -2 ion by accepting those 2 electrons. The other side of the worksheet, probably you have already gone over it, but let's do a little review. Metal ions are listed here, called cations. Non-metal ions are listed here, which are called anions. Before we come to compound formula, let's go ahead and do electron dots. So I'm working on the second example. Calcium with 2 dots, chlorine with 7 dots. Group 2, Group 7. Calcium has 2 electrons to transfer. However, chlorine has room for only 1. So it transfers 1 electron. Where will the second electron go? For that, we need to bring in another chlorine atom. So this chlorine atom has 7 of its own, and calcium transfers the second electron to this one. Electron dot of compound. Calcium, by losing 2 electrons, becomes Ca2+ or +2. There are 2 chlorides here. We put 8 dots around it, 7 of its own and 1 that came from calcium. Put it in square brackets and indicate with 1 negative sign that it has received 1 electron. There were 2 of them, so we will make yet another chloride ion with 8 electrons, 1 negative charge. So we just found that calcium carries a charge of +2, chloride carries a charge of -1. How do you write a formula? You need to crisscross the charges Remember, these charges are written as superscripts. When you write formula, it becomes a subscript. So you write calcium. Calcium gets a subscript 1 because of chloride. If it's a 1, you don't write it. Followed by chloride. Chloride gets a subscript of 2 that was transferred from calcium onto chloride. And the formula becomes CaCl2. Let's try another one. Perhaps sodium and sulfur. So let's try to do an electron dot for sodium and sulfur. Sodium belongs to group 1 and it has got 1 electron. Sulfur belongs to group 6, so it has 6 dots. Sulfur needs 2 more electrons to make an octet. The sodium can only provide it 1, so the second electron will come from a second sodium ion, which will be transferred to the same sulfide ion. So now we have 2 sodiums which have lost 1 electron each, and they become sodium 1 plus ion, sodium plus 1 ion. There are 2 of them. Both of these electrons went to sulfur, because of which now sulfur has 8 electrons. Its octet is filled. Because it received 2 foreign electrons, we will give it 2 negative charge. So sodium has a charge of +1, sulfur has a charge of -2. The step before writing its formula would be to crisscross the powers, crisscross the charges. Rewrite sodium. The subscript that sodium gets will be because of this 2. This 2 has been crossed over, so sodium gets a 2. And sulfur gets a subscript from sodium, which is 1. We do not write a 1. Hence, that is the formula for sodium sulfide. Lastly, polyatomic ions. Polyatomic ions, charges can be looked up from your formula chart. In your formula chart, all of these charges have been written. I'm randomly picking the last one here. Fe has a charge of +3. This is hydroxide ion, and it has a charge of -1. You can see it from your formula chart. So the step before writing a formula would be to crisscross the charges, rewrite Fe. Fe gets a subscript because of the anion. It is just a 1, so we don't write anything here. Before you write the polyatomic ion, put parentheses. Hydroxide gets a subscript from Fe, which is a 3, and that goes out here. If you don't put parentheses, then this 3 only applies to hydrogen, which would be wrong. So you put hydroxide within parentheses, put a 3 outside, so this 3 applies to both hydrogen and oxygen.